It is the intent of this report to look at the risk assessment and risk management strategies that are associated with the dam critical infrastructure sector. The report will provide a brief history of the dam infrastructure across the country and touch on the number of dams that are included in this critical infrastructure sector. This report will also look at the purpose and the significance of the risk analysis as it applies to the dam infrastructure sector. A comprehensive risk assessment and risk management strategy will then be developed, followed by the identification of the major threats, vulnerabilities, and risks associated with this sector. Once the threats have been identified and the risks have been assessed, a discussion of the possible recommendations will be presented. The report will conclude with a summary of the findings and recommendations, and it will include the writers, myself, input on the dam critical infrastructure sector and how it might impact the safety and security of our nation. History of dam infrastructure. The construction of both dams and levees are an essential part of our country's infrastructure. These structures were built to control flooding, provide hydroelectrical power, provide for irrigation needs, and to provide a source of water to the areas they are constructed near. In addition to these infrastructure components, the lakes that are created by the dams provide recreational, fishing, and boating opportunities for visitors and the community. Today, there are over 91,000 dams across all 50 states that serve an important need for our country. Of these 91,000 dams, over half of them are privately owned and maintained. The dams can be classified into two major groups based on their construction. There are both concrete and earthen dams that are included in the dam critical infrastructure sector. Based on their date of construction, the average age of these dams is well over 50 years. Based on this fact, most dams were constructed with a life expectancy of 50 years. The majority of the dams are in need of constant maintenance and repair. While most of the dams provide for recreational purposes, it is estimated that only 3% of the dams were constructed for hydroelectrical power. The remainder of the dams were constructed to impound water to reduce flooding of downstream communities, provide a water source to the community, and provide water for irrigation purposes. Dams were constructed along waterways to aid in the navigation of rivers and provide for the shipment of goods. The federal government established the dam sector as part of the U.S. critical infrastructure sector in 2003. This sector was established because the significant economical, environmental, and social contributions have on the country's assets and resources. Since its creation, the dam sector has built partnerships, improved the sharing of information, and developed best practices that can be shared with all stakeholders. Purpose of the risk analysis. The purpose of this risk analysis is to look at the current status for the over 91,000 dams, which are included in the critical infrastructure, and to identify potential threats that can occur to any one of these structures. Risk analysis methodology for dams began within the Department of Interior, Bureau of Reclamation after the failure of the Teton Dam in 1976. This was the time when many of the current dams were either in construction or just completed. The Department of Defense, U.S. Army Corps of Engineers did not begin utilizing risk analysis until after the levee failures during Hurricane Katrina in 2005. Dam safety practices over the years have included risk assessments, and they continue to be improved based on the knowledge, scientific understanding, and technological advancement in the engineering field. Significance of the risk analysis. When dealing with the dam infrastructure sector, there are multi-hazardous interactions and risk assessments. These relate if the dam is a concrete structure or an earthen structure. In addition, there is a relation to whether the hazard is a natural disaster or a man-made disaster or even a threat. The dam infrastructure sector can face multiple hazards simultaneously, such as a structural failure caused by an earthquake, which then results in flooding of the downstream communities. Both man-made disasters and natural disasters can lead to a major property damage and even the loss of lives. The major significance of risk analysis will help the dam infrastructure sector stakeholders identify the potential threats that might occur, identify changes or maintenance issues that need to be addressed, and help with the continued inspection of the dams as they continue to age. It is the ages of the dams that are of most concern, since they require more maintenance and funding for these structures is limited. Until the dams were identified as a critical infrastructure sector, their maintenance and care were just taken for granted and many of them were forgotten about. Highlights of vulnerabilities, risks, and threats. When it comes to the dam infrastructure, there are a number of threats and risks that need to be addressed. Some of the main threats are as follows. Failure of the spillway system for both earth and concrete dams. The spillway failure could be the result of erosion to either the upper or lower ends of the structure. This will result in possible breach of the spillway, causing flooding downstream. The vulnerability for this issue would be low if the structures were constructed properly. The actual chances for this threat would be considered low. The spillway could also be blocked, resulting in minimal flows of water. This will result in the rising of water in the lake behind the dam. This could cause overflowing of the dam. For concrete dams, this may not be a big problem. However, for earth-filled dams, it could cause erosion of the dam and lead to failure of the dam. Depending on the area, this could be a constant maintenance issue and could be reoccurring. The chances of this type of a threat should consider moderate and may result in minor flooding downstream when the blockage is removed. Seismic failure of the dam and spillways should be considered throughout the country, but in the earthquake areas, the chances is larger. Dams along the West Coast and the Midwest are more concerning. Since this will be a natural disaster, the threat should be considered moderate. The results of a failure of this type could be catastrophic. Total failure of the dam would be another concern. Since there are many different reasons this might occur, each case should be considered separately. The probability of this occurring would be considered low for many of the dams. However, the private dams might be a concern. Overall, the threat of this happening should be considered low to almost non-existent. For the dams that provide water for the communities, the threat of contamination of the source should be considered. This threat is real concern and should be considered elevated to high. There are so many ways water can be contaminated, and the threat of this causing the community to run short of water will be very high. The vulnerability of water contamination should be considered as high as well. The loss of hydroelectrical power is a concern for some areas of the country. The West Coast states rely on hydroelectrical power far more than the plains and Midwestern states, even though only approximately 3% of the power comes from hydroelectric power generation. The loss of power could be devastating on some communities. The vulnerability of this type of failure should be considered moderate with the occurrence considered low. Hydroelectric generators should be the only issue with this threat. The power transmission lines would fall under a different critical infrastructure sector. Terrorism is a threat to all of the critical infrastructure sectors. When looking at the dam sector, terrorists can cause damage to spillways, the entire dam itself, the hydroelectrical generators, computer systems running the dam, and water contamination. This type of threat should be considered high and the severity could be catastrophic. On the major rivers, terrorist threats could also include damage to the locks, which could interrupt barge traffic and the transportation of goods by water. For earthen dams, the slope stabilization would be another threat to the stability of the dam. As the water rises and lowers behind the dam, seepage paths are developed. This type of path is normal. However, if not monitored, it could lead to a failure of the dam. With a properly constructed earth dam, this would not be an issue. However, since seepage does occur, it needs to be monitored and repairs made as needed. The vulnerability of this type of a failure occurring is low, but it can result in catastrophic failures. Cybersecurity risks are also a major concern today. The chances of a cyber breach should be unlikely, however, there is still that possibility. Depending on the purpose of the dam, the vulnerability will differ. The threats related to a cyber attack could include opening water control gates at the wrong time, shutting down power generators, changes to water flow to the community, or irrigation needs, just to highlight a few. This threat is very possible and the consequences could be great. Changes to the watershed could also be a threat to the dam and the communities around the dam. Changes both upstream and downstream can have an impact on the operation of the dam. These changes could be the result of landslides, additional runoffs added due to the construction activities, and with the changes in the weather. Additional water runoff can also impact the dam. This causes should be considered low, and the chances of it occurring would be minimal. Results and recommendation actions. Failure of a dam can result in flooding that can cause loss of property, even loss of lives. It can cause the disruption of water treatment plants, wastewater treatment plants, hydroelectrical generators, roadways, and communication. There are steps and actions that can be taken to reduce the risk of a dam failure. Let's look at possible results of the threats identified and suggested recommendations that might be taken to reduce the risks. While spillway failures do occur, they normally do not cause a threat to property and life if they are addressed promptly and efficiently. In order to minimize the issues created by the erosion, proper maintenance inspections need to be conducted. While this does cost money, these types of inspections need to be included in the yearly budget. In order to get assistance with the inspections, the community could assist in training exercises and learn what to look for and document damage. This will greatly reduce the risk factor for this threat. Similar to the above recommendation, a blocked spillway should be identified during inspection activities of the dam. Again, this type of a preventive action should be considered normal maintenance and should be budgeted into the program. Cleaning out the spillway periodically if blocked would result in less water flowing at a single time and reduce the chances of flooding. This will greatly reduce the risk factor for this threat. Seismic failure of the dam and spillway, while it is a concern, should have been addressed during the original design of the dam. While the design requirements have changed since the 1960s and 70s, when a lot of the dams were constructed, they should withstand most of the earthquakes. Retrofit construction can be constructed to reduce the risk threat. However, the cost of these types of repairs might be more than the cost of constructing a new dam downstream. Earth dams will be the most vulnerable for a seismic failure, so additional monitoring would help reduce the risk of failure. Total failure of the dam is the most catastrophic case for a disaster. While the chances of a total failure are slim, there still needs to be a risk analysis performed. To help reduce the effect of a total failure, there might be a need to remove any traffic on the dam. This was done at Hoover Dam when they rerouted the highway across the river over a bridge and removed the traffic off the dam. Changes like this are very costly, however, it can reduce the risk and possibly save property damage and the loss of life. Contamination of the water source is a threat to the communities around the dam if it is used as a local water source. While this threat is possibly at any water treatment facility, contamination can occur prior to reaching the facility. This is a challenging threat on a large body of water, and only additional inspection and testing of the water supply can help eliminate any problems. Additionally, communication with other water treatment facilities can reduce the risk of any contamination. In dealing with the hydroelectrical generators, since most of these are within the dam structure itself, the protection should already be addressed. Since only 3% of our total power is by hydroelectric, the generators would be less of a target. The threat of the actual power lines falls under the jurisdiction of the other critical infrastructure sectors. Terrorism is a threat around the world. When it comes to the dam critical infrastructure sector, terrorists can attack several areas and try to cause catastrophic damage. Added vigilance is needed to reduce the threat of a terrorist attack. The best way to reduce this threat is communication within the community and with state and federal law enforcement agencies. Stabilization of the earth dams is a definite threat. With the changes in the water depth, especially on the Earth's dams, seepage can and will occur. In order to reduce the risk of this type of threat, added inspections can be performed. With these inspections, any problems can be observed early and corrective actions taken. This should be considered routine maintenance and projected in the annual budget. The community can help with the actual field inspections. Cyber attacks are a current threat to almost every industry. When it comes to the dams, it can affect the opening and closing of gates, operation of hydroelectrical generators, and lock gates. This can add additional water downstream and flood low lands. The best way to reduce this threat is to ensure the latest software is installed and all virus protection programs are up to date. While this is probably the least of the threats, it is a condition that is likely to be overlooked. As communities continue to grow, the amount of grassland is shrinking. This will increase the amount of water runoff and result in more water flowing off the watershed. This can be controlled by the permitting process and having the engineers look at the impact it will have on the water storage area. This is a very low risk item but should not be forgotten. Membership in the National Dam Safety Program will also help reduce the risk of dams. This program is a partnership with state, federal agencies, and other stakeholders that have established maintenance programs to help reduce the risk to property damage and the loss of lives. There are additional programs that have been developed to look into dam safety and will have recommendations that can reduce the risk of the dam infrastructure sector. Conclusion. Today, engineers can no longer ignore the information and benefits that a risk assessment might have on a project. During the development of a project, managers need to develop costs, schedules, and set performance goals based on risk analysis. This will address risk on the design of new projects, but the risk associated with existing projects needs to be addressed in the annual maintenance program and budget. Product risk analysis along with annual inspections of all dams is required under the federal guidelines for dam safety. Obtaining the necessary funding today can and will always be a challenge. Another challenge that is needed to be addressed is the replacement of experience and institutional knowledge of the engineers. Since most of the dams were constructed during the 1960s and 70s, the institutional knowledge of the engineers is gone, and new, younger engineers are taking their place. While the new engineers have textbook experience, they do not have the actual historical knowledge the older engineers have when it comes to the dams. Dams are part of the critical infrastructures whose safety must be properly maintained. While most traditional decision-making approaches are stationary, dam risk is susceptible to evolve with time. Risk can no longer be considered as static, but it should be considered a real-time process which constantly changes. Obtaining the necessary funding to maintain the critical infrastructure of the country today is getting harder and harder to obtain. Unless funding becomes available, our critical infrastructure will continue to deteriorate. Dams, while not always thought of as part of the infrastructure, do play a very important part of our community. Dams provide water for communities, irrigation for our crops, power to the western states, and recreation enjoyment to the community, both local and from the tourists. Without the dams, we will be unable to utilize major rivers to transport goods and services.